Vertical takeoff. It's a thing that we in Estonian Army or Estonian Air Force can't even dream about. I mean, our Air Force doesn't even have any weaponized planes. I think maybe we have 1 or 2 seaplanes, that's it. Estonia's air security is done by countries in the NATO. Right now it's supposed to be done by Italy, I think. Denmark does it, Germany does it, even. We don't have our own Air Force. But we can dream, I can dream. So today we're going to watch vertical takeoff. It looks so cool, it's like a sci-fi thing from the movies, but it really exists. Some of world's jet fighters use vertical takeoff. So let's see. The channel is Real Engineering. I think a lot of you know it because it has 3.1 million subscribers. A lot of you guys know the channel, so you know it's gonna be good. It's quality. My friends, I'm a fan of simplicity and I'm a fan of quality. So if you combine simplicity and quality, you know what comes out of it. Finland. And subsequently Estonia, because we share the culture, we almost share the language, we share the anthem, we have exactly the same anthem, and we kind of share the geographical location. You could say we're the same country. Finnish don't want to say that, but we Estonians, I mean, I wouldn't have anything against it to be a part of Finland. This is what comes out of Finland. This is a Rohje wristwatch. Both of them are Adventurizer wristwatch, but if you click the link in the description below, you can also check out their Artur wristwatch. They're really cool. They have pink ones, blue ones, black ones, metal ones, leather strap, not just any leather, reindeer leather strap ones. They have everything you need. If you don't have a wristwatch, go and get one. Link in the description below. Rohje, my friends. Before we jump into the video, of course, there are Patreons as usual. I never skip them and I never skip any Patreons. If you haven't seen your name, it might be because very rarely, some of my videos are blocked by YouTube. For example, if I would do a video about Afghanistan right now, I would be instantly blocked from YouTube. So I made a video about Restrepo, blocked from YouTube. So I can't make certain videos and some patrons' names are in those videos and they're blocked and then they figure why they weren't mentioned. Well, we have 3 new names today. Tails Doll, thank you for becoming a patron. Thank you for supporting the channel, my friend. Jesus, we have Jesus Madrid on our side. Jesus, I feel the light of the Lord. Well, thank you, Mr. Lord of Heavens, for becoming a Patreon. Dominic Rakes, thank you for supporting the channel. If you want to be like Jesus, become a patron of this channel. The link is in the description below. And also remember to be a patron tier 10 and above. Alright my friends, let's see what this vertical takeoff is all about and if I can have some for myself.
The sight of a 9.4 ton plane slowly rise off the ground, balancing precariously on 4
Wait, 9.4 ton planes? You wanna tell me the tanks are heavier than planes 4 to 5 times? Merkava tank, 64 tons. Abrams tank, I think it's about 60. And the German, I forgot the name, that was also really heavy. So these planes, they're bigger than the tank, but they weigh less. Wow.
volumes of air over the rough water of Galway Bay is the closest to sci-fi alien technology I have ever seen in my life. An inspiring sight that seeded an obsession with aviation technology. The Harrier was the culmination of decades of bizarre experimentation to eliminate the plane's greatest weakness, its need for a runway to both land and take off. This fascinating technology has one of the richest histories in aviation, with roots in both the lunar lander and outlandish World War II era German sketches. Both the Allies and the Germans used helicopters and autogyros during this period, but using a rotor for both lift and thrust inherently trades off speed. The Germans dreamed of a plane capable of taking off from anywhere, eliminating the need for tactically vulnerable airstrips without sacrificing speed or dogfight capabilities. Inspired by their ballistic missile program, which still lacked effective guidance programs to accurately target Allied aircraft, Erich Bochum developed the tail-sitting, rocket-powered BP-349. Which would allow the pilot to take control of the plane in its final stages of flight to guide it to its target and unleash a barrage of smaller rockets before ejecting to safety.
Damn, the Nazis had some crazy weapons and crazy ideas. How did they do it?
The only manned test of this aircraft resulted in the death of the test pilot, and the idea was abandoned. But that didn't stop the Germans in their pursuit of VTOL aircraft. Next up was an even more bizarre tail-sitting aircraft that featured 3 propeller blades, each powered by ramjets at their tips. This would function similar to a helicopter for takeoff and then transition to forward flight and use the blades like a giant propeller. but it would require a nose-up position to achieve adequate lift, as it didn't have any wings. Unsurprisingly, this didn't make it past basic wind tunnel testing, but could well have inspired the Lockheed XFV and Convair XFV Pogo planes in the 1950s.
What is this? This plane is supposed to be like that upside down. If you're a pilot, if you want to get up here, you need a ladder. I mean, you need a ladder for a regular jet also because they're so tall. But this one has propellers in the nose of it, on the front. It's a very World War II looking plane, but you put the plane on the ground the wrong way, my friend.
Which used massive counter-rotating turbo propellers. The Lockheed version only ever managed to hover for a brief moment while transitioning from a horizontal flight to an upwards vertical flight, but the Convair XFV Pogo, flown by Lieutenant Colonel James Coleman, became the first aircraft in history to successfully fly in both forward aerodynamic flight and in hover. Ultimately, both planes were cancelled due to the difficulty in flying them and their lack of speed and lack of lifting power. Engines for propeller-driven aircraft were simply not powerful enough yet. To achieve necessary lift, the rotors would need to increase velocity or diameter, which would decrease the max horizontal speed of the aircraft, as the tip speeds of the blades would rise, meaning the tips of the blades could easily break the sound barrier and cause all kinds of problems. This problem and how the incredibly versatile Osprey solved it needs a video by itself to explain the nuanced design of helicopters and their speed limits, but for now you'll just have to trust me that it's a difficult problem to solve. And with the advent of powerful jet engines, the problem was largely solved without the need for large propellers. The first aircraft to use jet propulsion for vertical takeoff was the Rolls-Royce thrust measuring rig, aptly nicknamed the Flying
Rolls-Royce. Well, they made aircraft engines, right, back in the day. I think they still do them. And they also make the most expensive cars in the world and the most luxurious ones, of course. But yeah, if you didn't know, Rolls-Royce made aircraft engines, now they make also cars. Mitsubishi in Japan made Zeros, the Japanese fighters, and now they make cars. And Saab, the Swedish car manufacturer, they sold out to China, I think. They make planes also, they made cars, and I had a Saab. It was a really crappy one, it was broke. So those three companies make planes and cars. BMW used to make motorcycles only, but now they make cars also. And Mercedes never made planes. I think I've never seen a Mercedes plane.
Bedstead, for its obvious departure from the bird-like designs of the past. This configuration largely influenced the design of the lunar lander training vehicle that NASA developed for Neil Armstrong and other astronauts to practice with. They mounted the engine on a large gimbal to ensure that thrust always pointed directly downwards and only provided enough lift to simulate the moon's gravity, while hydrogen peroxide rockets were used for control. Neil Armstrong attributed the success of his difficult landing on the moon to this ingenious training vehicle. The lessons learned through early research aircraft like these provided Rolls-Royce with the knowledge required to develop the Rolls-Royce Pegasus engine, which powers the Harrier. This engine needed to have enough thrust to lift the entire weight of the plane. The designers of the plane made this job easier by utilizing carbon fiber composites for much of the aircraft structure to save weight, making the Harrier one of the first planes to use these materials. Yet the job of designing a single engine capable of providing enough vertical thrust was still difficult, and the resulting engine is pretty unique as a result. The engine is similar to a traditional jet engine in that it consists of a low-pressure compressor fan, a high-pressure compressor, a combustion chamber, a high-pressure turbine, and a low-pressure turbine. Where it differs radically is the engine outlet is not just one large opening, but split into four, where the first two nozzles duct some of the air coming from the low-pressure compressors and the final two duct air from the higher-pressure turbines. Because the air bleeding from the low-pressure compressor system has less force than the high-pressure nozzles, the low-pressure nozzles need to be placed further from the plane's center of gravity than the high-pressure nozzles. This balances the plane along the length of the plane, but in vertical takeoff mode, there is no air flowing over the wings to provide force for the control surfaces. So the plane needs a way of controlling its roll, pitch and yaw in vertical takeoff mode, and so the plane features nozzles that bleed air from the engine on the nose, tail and wingtips. This control system is not as reliable as aerodynamic lift, which is largely self-correcting when disturbances occur, although fighters tend to purposely decrease stability to increase maneuverability, which requires a computer to constantly monitor.
Okay, this is a lot of text from me right now, and as a simple soldier, as an infantryman, I don't understand quite a big chunk of it right now, but I hope you do, and it's very interesting to watch for me. But I think to understand everything correctly here, I would need an education in engineering and rocketry engineering or something, but still, real life engineering is very interesting to watch. I watch those videos, but I don't claim to understand even half of them.
The disturbances due to the ground effect from its own jet can cause oscillations that overwhelm this control system, and with no accurate way of correcting them, they can grow until the plane inverts and lands on the cockpit, which has killed pilots on several occasions. So pilots often drop the plane heavily from a few meters above the ground before the oscillations could take hold, which obviously wasn't ideal for the landing gear. The Harrier was also disadvantaged to conventional aircraft as the vertical takeoff mode was severely limited in max takeoff weight and burnt off much of its fuel in this intensive maneuver, reducing its range too. So most Harrier takeoffs take place only as a partial vertical takeoff, where the plane would accelerate on the runway like a conventional plane to achieve some lift from the wings and then angle the nozzles to achieve the final lift needed to safely take off.
Yeah, I would imagine vertical takeoff takes a lot of fuel. If you're accelerating on the runway, you're using the wings to take off and you're using the air. I don't have the language or the intelligence to actually explain what I think I understand, but I understand that vertical takeoff is fighting every force you can. You're fighting gravity and you're not using the wind and the air. Going brute force with takeoff takes a lot of fuel, but if you're accelerating down the runway, it's like a more clever way to do it. It takes less fuel and it utilizes the air flows and the wind. I would imagine if you use vertical takeoff, your range decreases substantially. So if they can, as it is explaining right now, if they have the opportunity and they're not in a hurry or whatever and they have the airstrip, they're using the acceleration on the airstrip way to take off
On the shorter runways of aircraft carriers. The plane could then land vertically without wasting as much fuel later on when the weight of the aircraft had reduced through its use of fuel and armaments. This takes its max takeoff weight from 9.4 metric tons to 14, which is still lackluster when comparing to its fellow marine aircraft like the FA-18 Hornet, which has a max takeoff weight of 23.5 tons and a maximum speed of 1.8 Mach, compared to the Harrier's subsonic 0.9, making it a much more capable attack platform. But the Hornet is only capable of launching from large carriers, whereas the Harrier can launch from amphibious assault ships like the USS America. The Harrier has even managed to land on a cargo.
Okay, you can understand why the British didn't make F-18 Hornet style aircraft. They made the Harrier because the British is they still have a huge navy. I mean, the US also have a huge navy. British, the military history is being all over the world with their ships and with their navy, and they don't have these huge aircraft carriers, and they have to make a plane fitted for their smaller aircraft carriers, and the Harrier can lift up from more platforms than the F-18 can. F-18 needs a huge runway and a very big expensive aircraft carrier. And if you have the money for it, like the United States of America, go ahead. You're gonna be the first military in the world, but Britain doesn't have that much money or that big aircraft carriers. That's why it makes sense for the Harrier jet plane, which can lift off from a much wider list of platforms. And if it needs to, it can totally lift off from anywhere actually.
Ship when its pilot lost radio contact with his crew and ran out of fuel. But both of these fighters are slated to be replaced by the controversial F-35, which will be capable of VTOL thanks to the incredible directional rear thrust and shaft-driven lift fan. This fighter includes much of the technology the Harrier laid the ground for, while including
the F-35's vertical lift-off, and it being a very capable fighter with the big range and stealth capability. It's mind-boggling. Right, the Harrier had an edge on the F-18 because it could lift up from everywhere. The F-18 couldn't, and if it ran out of fuel it couldn't land anywhere. It needed its own landing strip. But the F-35, it can be anywhere, take off from anywhere, land anywhere. It's stealth, it's fast. It's an incredible aircraft for me.
Futuristic VR helmets allowing the pilot to see through their own
and the VR helmets, of course.
Infrared cameras surrounding the plane. Advanced laser targeting and radar capabilities, all the while incorporating stealth technology. The plane has been deeply entrenched in US politics, raking in huge developmental costs and supporting thousands of American jobs. It has been delayed again and again, largely due to its ambitious technological leap over its older counterparts.
It's a huge leap.
When it finally reach service, it will become the most advanced plane in the history of mankind. Each advancement, like this, is built upon the foundations of physics that humankind has learned over the course of our existence.
Crazy, I was again mind blown. Every time I watch a video about, I don't know, vertical lift of F-18, F-22, F-35, all of those planes, I am mind blown by something at least. All of these planes at some point had been the best in the world. I mean, the Harrier also was the best in the world at vertical takeoff, I think. They revolutionized the technology because the F-35's vertical takeoff systems are largely based on what the Harrier jet technology did by research and everything like that. So they couldn't do the F-35 vertical liftoff if there wasn't experience from the Harrier. So all of these planes still are enough to mind blow me. An infantry soldier from Estonia. Well, I'm not very difficult to mind blow. A small bit of new information, I'm like, oh, what? That's the best in the world. We need them in Estonia. We need Harriers in Estonia. We need F-35s in Estonia. USA and Britain sent them to us. We are your eastern border. We're the border of NATO, so we will protect you from the big bear. My friends, thank you for watching these videos. Thank you for learning with me. If you like the videos, subscribe please, and also become a patron. The link is in the description below. And also remember to become a patron tier 10 or above. Then I will read your name also, and you'll be in the Hall of Fame forever. And as always, my friends, until my next video, stay cool and bye bye.